Hi, my name is Cowboy, and this is my final project, Gazer. Gazer follows your on screen eye position and accepts voice commands only when you're looking in a certain area. I've added a few new features since the last demo. The first is a help menu that allows users to see which voice commands are available in a given view. Secondly, I added a new use case. I've already demoed YouTube and website navigation with Gazer, but now I've implemented video chat. I came up with the idea after a Zoom call with family where everyone was talking over each other, and I really only wanted to talk to a few people one at a time. With Gazer, this is possible. Let's see it in action. Cool, so this is the calibration screen. Here are the instructions, and I'll go ahead and calibrate. Hey Salome, can you hear me? Salome, can you hear me?
Yep.
Cool. Let's just wait for Rio. Oh, there he is. Hey Rio.
So,
Okay, so Salome, can you make a pretty annoying sound that I wouldn't want to hear on a video chat?
yeah.
Okay, so Rio, it'd be hard for us to talk, I think. So I'm gonna go ahead. Yeah, perfect. Enable focus mode. Rio, can you hear me now? You're lagging a bit. Can you hear me?
Yeah, I can hear you, but very, I envy the fact they don't have plugs in those first line.
Yeah, let me check in on that. All right, cool. Thanks, guys. I'm gonna hang up now. Hang up. Now that we've seen the demo, let's see how it works. This is a user, and this is their iPad screen from a top-down view. The system first gets a transformation of the user's eye using Apple's ARKit. Then it converts the eye transformation from the local face coordinate system to the world coordinate system. After that, it projects lines along the orientation of the eye and intersects those eye lines with the iPad screen, which in this case is just a plane. Finally, since eye tracking is not perfect, the eye lines aren't necessarily guaranteed to converge on the iPad screen. To fix this issue, we simply average both the intersections to get the estimated gaze position. The next step is calibration. This is again an iPad screen where the red dot indicates the estimated gaze position. Before calibration, the system's accuracy is pretty bad. For example, if we look at the lower left-hand corner of the screen, the estimated gaze position might be somewhere in the middle of the screen. Similarly, this is the case for the upper left hand, upper right hand, and lower right hand corners as well. This trapezoidal shape is pretty indicative of the system's response before calibration, where near the camera, the tracking is better, and the further away you get near the bottom of the screen, it gets worse. The process of calibration involves mapping these 4 points, and all points inside of the shape, to the 4 corners of the iPad. This can be done using something called a homography matrix, which maps one set of points to another. However, since we're using more than just 4 points for our calibration system, and there's a lot of noise involved with eye tracking, we need to take a randomized approach to estimating the homography matrix. And we can do this using an algorithm known as the RANSAC algorithm. I implemented this using OpenCV because Swift support for matrix operations is pretty limited. The final part of the system is the command recognition menu. It waits until the user is looking at it, and only then does it begin recording and accepting voice commands. It also delegates the actual processing of the command to the parent view controller, so that different use cases can use the same menu, but respond to commands in different ways. The part of the system that actually processes and transcribes the command is the Apple Speech Framework. And this is a callback function that receives the current prediction, which I then use to update the various UI elements. I also added a timer that detects when the user has finished talking and then turns off both the speech framework and the recognition menu. Overall, the system works pretty well, but unfortunately, I still think it's necessary to have the red gaze indicator overlaid on the app in all screens at all times. And this is because the eye tracking isn't quite good enough yet to work without it. Sometimes the estimated position is just a little bit off and you have to adjust your gaze to make it work. One weird failure that I noticed was dealing with the homography matrix. When the estimated gaze is not contained by the calibration points, then it might flip the direction or move it to some place on the screen that's not even close to where you're looking. And one probably easy fix to that is just to clamp all points outside of the calibration shape to be inside of it. Thanks for listening.